Let's go to circular motion. Circular motion is the motion of a body moving on the circumference of a circle. When there's a circle like this, and a ball runs around the circle on its circumference. Let's say a ball runs around this circle on its circumference. That ball is performing what is called circular motion. Or let's say this is a turntable disc, and you kind of, glue a small stone to this spot. So as the disc moves around, the stone will travel around and come back to that same pot or that same point, while the disc is not actually moving, it's just turning about its own axis. So the disc is performing spinning or rotational motion, but the stone performs circular motion because it goes around, comes back to its original position, goes around, comes back to its original position, and on like that. So that's circular motion, motion of a body around the circumference of a circle. So let's give some examples of objects performing circular motion. A stone wired round in a circle. You know what happens when you tie a stone to a thread? If you tie a stone to a thread and tie the other end of the thread to your finger and roll it around like this, that stone is performing circular motion. Then a car moving in a circular path. If a car goes around, a roundabout in complete circles, we say the car is performing a circular motion, and so on and so forth. Relay runners too. Those running 400 meters, 1,200 meters, and so on. If they go around several times, you understand? Each motion around the circular field or around the circular track of the field is a circular motion. So there are many other examples that you can remember. So parameters used in describing circular motion. Let me try. Okay, parameters used in describing circular motion. There are several parameters used for describing circular motion. If an object starts at a point A and goes from that point A to B, it has turned an angle theta. Now, if that angle theta is measured in radians, the angle is referred to as its angular displacement in radians. Angular displacement is the, angle turned by an object moving around a circular path measured in radians, or angle turned in radians by an object moving around a circular path is what is referred to as angular displacement. Take note, I didn't write that. Angular displacement is the angle turned theta in radians by an object performing, circular motion around a circle, or circular motion on the circumference of a circle by an object performing circular motion simply. So let's go to the next one. Distance S, distance traveled. Now, in this diagram that I drew here, if this object goes around from point A to point B, it has traveled, it has turned angle theta. That's the angular displacement. But if you stretch this arc AB that it has formed, if you stretch it into a long length like this, and you measure that length on a meter rule or on a tape, that will give you the distance traveled by, that object from point A to B. So the distance traveled is the length of arc drawn when an object moves from one point to another on the circumference of a circle. I hope you are getting that. The distance traveled is what? Is the length of arc drawn when an object moving in a circular path moves from point A to B. So, very simple. Distance traveled is given by what? S. And if angle theta is measured in radians, S is equal to R times what? Theta. S is equal to R times theta, where R is the radius of the circular path. So take note of that. Next is what? Angular speed. Let's take the next parameter, angular speed. I'm sorry I didn't underline this. I should underline my titles. Let me do this well too. You use your ruler to underline your headings. Very important. Let's go to angular speed. Angular speed is the angular displacement per unit time. The angular speed of an object moving around a circle is the angular displacement per unit time. So take note of that. The symbol for angular speed is W. So angular speed W is what? Angular displacement over time taken. Or you can define angular speed as angular displacement per unit time. Angular speed, the angular speed of an object moving in circular motion is the angular displacement per unit time. So W is what? Theta over T. Theta is in radians, time is in seconds. So the angle turned is in radians, the time taken is in seconds. So that means W is in what? Radians per second or rad per second, like this. So take note of that too. Number 4 is the linear velocity. The linear velocity. This is the tangential velocity or speed of an object performing circular motion at an instant in the motion. So it continues to change. If an object starts moving here now, from here, on getting to this point, its tangential speed will be, a line drawn as a tangent to the circle. That's the linear velocity or tangential velocity or tangential speed. Any of them is an equivalent is an equivalent term used for linear velocity. So on getting to this point too, its linear velocity will be the tangent to that circle. So that means this speed, you understand, its value remains the same. Its magnitude is constant. Its magnitude is what? Constant. It is constant in magnitude. Linear speed is actually constant in magnitude, but what? Changes in direction. Changes in what? In direction. That's another point you must know about linear speed or the tangential speed of an object performing circular motion. So take note of that. Let's go. Okay, formula for linear speed V. Linear speed V is what? The distance traveled over the what? Time taken. So speed V is distance traveled over time taken. Now distance traveled is in meters, time taken is in seconds. So the SI unit for V is what? Meter per second or meter second raised to power minus 1, like that. So V is equal to S over T. But we know S as what? R theta. Previously, we showed that S was what? R theta here. We know S as R theta. So that if you look at it very well, linear speed S over T will now be what? R theta over T. If you rearrange this to R times theta over T, V will be R times W, since W is what? Theta over T. You understand? Previously we said angular velocity is what? Angular displacement over time taken. So linear velocity will now be R times W, which is radius times, angular velocity. So take note of that. Next is centripetal acceleration. Centripetal acceleration is the force per unit mass acting on an object in circular motion. It can be shown that A is equal to V squared over R. So using V as RW, A is equal to V squared over R can be written as RW squared over what? R. So that's R squared, W squared over R. R will cut R squared. You have RW squared. So that means our linear acceleration or centripetal acceleration is RW squared or V squared over R. Take note of that too. SI unit of A is in meters per second. It's meters per second, like this, or M per second square. Meters per second square, like this, or what? M/second square. Centripetal force. This is the force acting towards the center of a circular path and keeping an object in circular motion. Centripetal force, Fc, is what? Mass times centripetal acceleration, which is mv squared over what? R. So centripetal force is, m times rw squared. Since linear acceleration is what? RW squared. Centripetal force 2 will be mv squared over r, or mrw squared. So take note of those equivalent quantities or formulae. Next is what? The period of an object performing circular motion. Period is the time taken to move around the full circle once. You understand? Period is the time taken to complete one cycle of motion. When an object moves in a circular path, the period of the object or the period of its motion is the time taken to complete one cycle. You can write the English anyhow. Time taken to complete one cycle, time taken to move around the full circle once, and so on and so forth. In radians, the distance around the circle is given as 2 pi radians. You know, time is meant to be distance traveled over what? Speed. So that means if distance traveled is 2 pi radians, when something goes around one full cycle, it has traveled an angular distance 2 pi radians. You understand? So if the distance traveled is 2 pi in radians, the angular speed w is what? W in what? Radians per second. So using time is equal to distance over speed. Using time is equal to distance over speed. Time taken to travel one full cycle is equal to distance traveled in one full cycle over speed of motion. That means time to go one full cycle will be equal to what? Distance of one full cycle over the angular speed. That's 2 pi over w. So if you look at the units very well, radian will divide radian and second will go up. So you have your answer in what? Seconds. Look at this very well from here. If you look at it very well from there, radian divided by radian per second will be equal to what? Radian will be equal to what? Radian times second over radian. So radian will cut radian and your answer will be left in seconds. So that means our formula is actually correct. You understand? If units show that your formula is correct, that means what you have written is correct. If units simplify correctly, that means our formula is what? Correct. So that means period is what? 2 pi over w. Take note of that formula. Since radians, okay, I've shown that more here. Hence, period is 2 pi over what? W. And it is measured in second. Frequency, the period of motion is measured in second. Frequency, this is the number of complete revolutions made in 1 second by an object performing circular motion. The frequency of an object performing circular motion is the number of complete revolutions or complete cycles moved in 1 second. So frequency is what? Number of complete revolutions over time taken. So number of complete cycles over what? Time taken. So frequency, SI unit is 1 over second, or second raised to power minus 1, or what? Hertz. So take note of that. Note, it can be shown that frequency is 1 over period, or period is 1 over frequency. Since period is 2 pi over w, frequency will be 1 over period, or 1 over 2 pi over w, which gives what? W over 2 pi. So the frequency of an object performing circular motion is W over 2 pi. Or W is what? 2 pi F. 2 pi times frequency. So take note of all that. Or we can write W as 2 pi times frequency, which is 1 over period. That gives W as what? 2 pi over T. We'll be using all of these in our calculations, so please take note. We'll be using all of this in our examples. So please take note. They are very, very simple, simple formulae for solving problems on circular motion.